Good afternoon, ladies and gentlemen. My name is Dirk Rebert from Coherent Shared Services BV, located in Dieburg. I am Market Development Manager for Laser Measurement Control Products, responsible for sales within the DACH region. Thanks to the Lane organization team for changing from a physical to a virtual conference this time, for the opportunity to present our novel measurement technology and improvements to this international auditorium. In the next 4 seconds, I will show you the diverse global sites that belong to Coherent. I will then mention current measurement technologies to measure power and energy of laser sources, followed by Coherent's novel power energy measurement technology PowerMax-Pro, how it works, applications, field of this new technology, and followed by a summary and our outlook. Unchanged since years, these are the main markets where Coherent, laser and laser systems, the main part of Coherent's business, as well as also instruments and components products, such as laser measurement systems, are used, and where Coherent continuously puts the focus and efforts to find new application fields, customers, challenges, and business. After Coherent's acquisition of Rofin and Divus included sub-companies in 2016, a further important change has happened this year. Succeeding the former CEO, John Ambrosio, Andy Mattes has been appointed as new CEO in April this year. You are seeing all Coherent's manufacturing and development locations globally at this map, and especially in Europe. Numerous locations have added to the Coherent family until now. Worldwide, we are now about 5,100 employees. Now my focus goes to the Coherent LSM, Laser Systems and Measurement Business Unit, with about 170 employees, which is located at the northern west part at the coast of North America in Wilsonville, Oregon, close to Portland. I'd like to summarize some key details to you about the current known laser power energy measurement technology in detail. I strongly assume many or even most of you have once used a laser power energy sensor to measure the power, the average power, the energy, the pulse width, etc. of a laser source during your career. In the following 3 slides, I'd like to briefly explain the advantages and difficulties of current laser power energy measurement sensors, certainly depending on where and how they are used. Thermopile sensors, power measurement sensors, are designed for measuring power ranges from microwatt to multi-kilowatt. They are durable and withstand intensities up to multi-kilowatt per square centimeter, but depending on the model, they are sometimes slow in response, speaking in up to several seconds. Semiconductor laser power sensors are very different. Those are mainly highly sensitive. Speaking of nanowatt, they are fast in their response, nanoseconds, microseconds, but they can't be used for higher power ranges, often not more, for just a few 10 milliwatt. The third broadly known physical measurement methods are pyroelectric sensors, ideal to be used for pulsed laser sources from single pulse up to the multi-kilohertz range, very fast in response, but those are not too durable and not usable at all for the use with CW laser sources. After this brief summary, I'd like to now switch to our main topic, our new measurement technology. The ideal properties of the just mentioned 3 technologies combined in one novel sensor technology is what Coherent made to its new R&D challenge years ago. Now since about 4.5 years available, called PowerMax-Pro, the next generation laser sensor technology. You might ask yourself now, what is the principle at the bottom of this novel measurement technology? It's a complex thermoelectric, thin-film, multi-layer technology. Let me explain this, please, by comparing a current measurement technology with the novel technology. Measuring laser power with a power sensor based on a conventional thermopile can take up to several seconds, as the incident laser beam that hits the sensor causes a change of surface temperature which must travel radially to the thermocouple junction ring pattern at the outer circumference. Thus, the generation of a measurement signal can last up to 10 seconds. In comparison, the instant response of this novel technology is about 1 million times faster, responding in just microseconds, as the light must travel only transverse through this complex and only a few micrometer thick thermoelectric layer, generating a short heat flux, finally a voltage. This complex structure is contained on a superconductor called Seebeck effect. Comparing these two physical measurement technologies via these measurement signals, looking at the red curve, you can clearly see the delay until the measurement value has stabilized. With the new thermoelectric PowerMax-Pro technology, the blue curve, an instant response of smaller 10 microseconds results. The application fields. Where does it make sense to use this fast responding technology and what benefits might result? Optical alignment, optimizing diode to fiber, beam train optimization, CO2 laser turn on off. All such applications might need or require a fast sensor response. CL3, a PowerMax-Pro sensor integrated in a closed-loop system for CO2 laser stabilization, externally attached to the CO2 laser head. At up to 400 watt and 30 minutes, a stability of 3 to 9% was achieved without closed-loop stabilization left side. On the right side, an impressive power stability of 0.2 to 1.3% was realized using the closed-loop PowerMax-Pro. PowerMax-Pro sensors can ideally be used for laser cutting and via drilling processes. Real-time measurement and in-process control are some of the major key properties. Increasing throughput and accuracy, quality for every pulse, important factors for especially the microelectronic processes. In these industrial fields of welding and precision material processing, time is one of the critical factors. Ensuring continuously ideal working laser systems, measurements have to be performed. The more often and the faster, the better, to reduce idle time where the laser does not produce. I'd like to summarize the most important key fact now. This new PowerMax-Pro technology, available as off-the-shelf and OEM models, can be used in the range of milliwatts through multi-kilowatt at a response of smaller 10 microseconds, and all this at full power and up to 20 kilohertz every pulse. Coherent already sees and hopes that especially the laser industry business area benefits from this novel technology and its nearly instantaneous response in order to reduce manufacturing costs, improve quality, and improve the end product. By the way, during the last 3 slides, one could have done up to 50 measurements with a conventional thermopile sensor or also 6 million measurements with a PowerMax-Pro. I'd like to finish my presentation giving you a short outlook. As you can imagine, Coherent receives diverse special requests and demands. Following this, the development of new modified standard models, as also further coatings, as well as new thermoelectric substrate form factors are in progress, with which we can hopefully help improving laser manufacturing processes. Thank you for attending my talk. I'm looking forward to your questions, learning about your applications, and meeting you in some of the diverse chat rooms. Please don't hesitate to contact me. And you can also rate my talk. Thank you a lot and see you around.